Here's a picture of the planet Mercury. And one of the great things about discussing astronomy is you can get all of these images from NASA that are all in the public domain. They're not copyrighted. You're free to use them anywhere in any way you want to, just as long as you acknowledge that they're from NASA. And that's where I get all these pictures from. And this is Mercury, the closest planet to the Sun. And it's a small planet, and I'll start off talking about its size and its orbit. It's just a little bit bigger than Earth's moon. The size of Mercury specifically is 0.055 Earth masses, so that would be 5.5% of the mass of Earth. And here's a picture that gives an accurate comparison of the size of Mercury to the size of Earth. And you might look at that and think, well, it looks a lot bigger than 5% of the size, and certainly the diameter of Mercury is bigger than 5% of the diameter of Earth. But we're talking about the mass, which would include the volume in all three directions and also the density. So that the mass of Mercury is pretty small compared to Earth. It's a little bit bigger than Earth's moon. Now the distance from the Sun to Mercury is measured in terms of what we call an astronomical unit. An astronomical unit is sometimes referred to as 1 AU, and that's a measure of distance. 1 AU is the distance from the Sun to the Earth. It's about 93 million miles. So that gives us a way to compare how far the other planets are from the Sun by comparing them to the distance the Earth is from the Sun. So the Earth, by definition, is 1 astronomical unit from the Sun. The orbit of Mercury is 0.4 astronomical units from the Sun. So you can use that to make a mental picture. If this was the Sun, and here's the orbit of the Earth around the Sun, about that far away, then the orbit of Mercury would be about 40% of the way, about 40% of that distance. So that gives you a picture of how Earth would sit and how Mercury would sit in their orbits relative to each other, as far as their relative distances from the Sun. And that's a good term to know, the astronomical unit. That'll show up over and over as we talk about the distances to the planets. Because Mercury is close to the Sun, it's hard to see, because when you're looking from the Earth toward Mercury, even if Mercury is at the extreme sides of the orbit, you're always generally looking toward the Sun. So it's most of the time it's visible during the daytime, and it's very hard to see, obviously, see things in the sky during the daytime. So some of our best pictures of Mercury come from right at sunrise or sunset, when the Sun might be just over the horizon and Mercury might be just above the horizon. And you could see that if Mercury were over here in the orbit, that you might be at a place on Earth where you're looking out at the horizon and the Sun is below on one side of the horizon and the planet Mercury is on the other. So you could see Mercury just before or just after sunset, depending on the relative orientations of the planets. But most of our best pictures of Mercury recently have come from spacecraft. The Mariner 10 spacecraft went to Mercury and photographed about half the surface of Mercury, and then the Messenger spacecraft went and is still up there actually. At the time that I'm recording this in 2008, the Messenger spacecraft is still actively working and returning data. Here's a nice high-resolution image taken by the Messenger spacecraft. And here's another. You can see some large impact craters and some of the activity around the craters where matter was sprayed outward in a radial fashion. And here's a really cool picture of Mercury transiting the Sun. That's the term astronomers would use to describe this. This little dot right down there, that's Mercury passing in front of the Sun. So it obscures some of the light from the Sun. It just appears as a little black dot. This big dot over here on the left, that's a sunspot. So you can see sunspots can be huge, much bigger than Mercury, much bigger than Earth, in fact, as well. This is a photograph of the Mariner 10 spacecraft that went there several years ago and took some photographs of the surface. And this is the Messenger spacecraft. In this photo, they're preparing it for launch, but it's out there right now. There's some interesting facts about Mercury that are worth noting. One is that it rotates very slowly. It rotates so slowly, in fact, that one day on Mercury is longer than 1 year. 1 year on Mercury would be defined as the time that it takes Mercury to go around the sun. And that happens in about 88 Earth days. So 88 of our days is the time for Mercury to take one complete lap. And as it's rotating around the sun, as it's orbiting around the sun, it's rotating around its axis, but it's rotating so slowly that one side of Mercury actually faces the sun longer than one Mercury year. And a year on Mercury then, or a day on Mercury then, is very, very long. And because of this, Mercury is a planet of extremes. On the sunny side, it gets very, very hot. The sun is up for months at a time by our reckoning of months. And the temperature can reach as high as 430 degrees Celsius. That's 800 degrees Fahrenheit. That's hot enough to set things on fire here on Earth. 800 degrees Fahrenheit. And then on the dark side, the planet is facing away from the sun for long periods of time, and a lot of the heat radiates away into space, and it can get down to about negative 180 degrees Celsius, or that's about negative 300 degrees Fahrenheit. So it can be very, very hot or very, very cold, depending on whether you're on the sunny side or the shadow side.